So we got to solve this question. Okay, so we need to find V out. So determine the output. Okay, so we need to find the output, which is V out of the signal, and then we're going to plug T. So as you can see, once we get the output, we're going to replace it with the time given. Okay, so we need to know that we got a unit step as our input, and then a transfer function. This is a transfer function. So this is a transfer function. Okay, so the transfer function, we know that the transfer function equal to V out over V in. Okay, and we know the question is to find V out first. Okay, so we're going to get V out and then also apply the inverse Laplace, so then we can plug the value of T inside the V out. So it's going just to replace, this is like you need to get the V out in T, okay, in times domain. So that is what you see, and then you plug the value of T there. So before you get to times domain of V out, you need to go first for V out in S domain. Okay, now there is something that we need to see. So now the question is the input unit step input. Okay, so and we should know that V in of S equal to the unit step input. So the voltage input equal to this. Now what is unit step input? Remember we saw earlier. Okay, if we go back to this table, you can see this is a unit step. Okay, the step. Okay, and this is in times domain, and as we're working with S domain, so we're going to stick to this. So the last table is the one that we're going to look at. Okay, and this, the one that you see, is the step input that we get. Okay, now there is this is when we have a step function. Okay, this is what we get. Now what is step input? Unit step input. Unit step input. Okay, let me say unit step function just to keep it the same. So in that case, we're going to have the same formula, but instead of having we're going to have 1. So it's because we have 1 on at the numerator, that's why we call it step input. So step unit means A equal to 1. That is the simple meaning. Whenever you see unit there, that means that A will be equal to 1. Okay, even here when you see A, this is the value of A. If it's not 1, we're not gonna call it a unit. It's only when it's equal to 1. When A equal to 1, then we call it unit. Okay, in simple terms. So this is the unit step input. So it's gonna be V in of S equal to 1 over S. Okay, so now we need to look into V out. How are we going to get V out? If we take this equation, we can multiply both sides. So I'm going just to write both equations. Okay, equality. I'm gonna put some space, so then I can multiply both sides with V in. Okay, if I multiply this side with v in, let me just use scalar, this side v in. Okay, what will happen? These two will cancel out, so I'm going to stay with only, I'm going to solve the equation. It's gonna be v out, so now it's gonna be v out s equal to h s v in s. So this is what I'm gonna get here. Okay, so now when I have this formula, okay, I know I know already what is hs and what is v in. So my equation will be something, so v out will be equal to 4 s plus 0 to 5, okay, then times 1 over s. So this is what I'm gonna get here. Okay, if I have to place a value, okay, so this is what I'm gonna get. Then I'm gonna have to solve for v out of s. It will be equal to 1 times 4, which is gonna give me 4 s, the denominator times the first denominator times the second denominator, gonna give meters. So it's gonna be what you see here. So this is v out, okay, this is v out. And if I want to solve this further on, so then I can plug the value of t into the equation. That's one we're gonna do it later on. So the idea was just to give you what you can go and how you're going to plug the value of v out. Okay, now, and how you can apply the unit step. Okay, and if you want the further step that you need to take, you need to check into the Laplace table. If there's no formula, you need to go for partial fraction. Okay, partial fraction. I will see later on if I can give you introduction to partial fraction, and then after partial fraction you take the inverse Laplace. After you take, so this is gonna be what you're gonna do after this section, and after that, and lastly, you're going to replace t into VR, because here this is where you're gonna get v out of t. Okay, after you take the Laplace transform, you will get v out of t, and then once you get v out of t, you're going to replace with t equal, it's gonna be t equal to 3.7 sec. So which is gonna be v out, we're going to replace the value of t with 3.7. okay, this is what you're gonna do on the last step. It's gonna be like replace t. That's what you're gonna do on the last step, and then you should be able to get the answer to this question. So for us, we're going just to stop here, because we wanted just to show you where you can introduce the unit step into your transfer function. Okay, so where you're going to replace your unit step. Okay, so, and also that depending on the way that you're going to represent, you can also write this function like this. This is also a transfer function. It's just a representation of the transfer function, depending on which how you're going to write it. Okay, so this is an example when you have to work with unit step.